Hey class, and welcome to the second category of food that we will learn about. And this would be the packaging of flesh foods. In your handouts, this comes before your horticultural product, so you just check on it, just go back one chapter. And that would be our main discussion for today, flesh foods. So this would be the outline. We'll be talking a lot about red meat, okay? So under red meat, we'll talk about the color and all the things that are affecting color of red meat. We'll also talk about the microbiology of red meat. Then there's also a very short topic on lipid oxidation. And finally, we'll talk about the different packaging systems for red meat, including vacuum packaging, modified atmosphere packaging, and packaging of frozen and restructured meats. Now, after red meat, we'll talk about cured and cooked meats. Then after that, we'll talk about poultry, which is still part of flesh foods. And then we'll talk about seafood. So the main discussion here would be about red meat actually. So sa punta na lang si poultry, seafood, and the other processed foods. Okay, so let's start with red meat. So in the packaging of red meat, there are two factors of major importance, color and microbiology. So this would be our very, very critical factors now. So in horticulture, we have learned about respiration and transpiration. But for our flesh foods, specifically for red meat, color and the microbiology of the red meat are very, very important. Now, between the two, color is more importanter. Okay, color is more important because it is likely to limit the shelf life of red meat. Why is that so? Why is it color and not the spoilage by microbes more important? Because when the consumers do not like the color, they will no longer buy that. Okay, they will no longer use that, even if it's still safe microbiologically speaking. But if the color has degraded, you won't buy that. Remember, I think you could also relate to that. If you're going to the market and you're going to choose your meat, okay, you always look at the color. So we will be discussing these two, and we will discuss color first in great detail. So let's start about color. So the loss of bright red color, also known as the loss of bloom. Okay, when we say bloom, that means, okay, by the name itself, I think you could imagine it's very bright red, very red. It looks really good, okay? And therefore, losing that color is affected by many factors. Although consumers will usually associate color loss with bacterial growth, but in fact, there are other factors affecting color. So the following all affect the color of red meat. We have here the pigments, which we know as myoglobins. I hope you remember this from our first lesson. Oxygen, color intensity, light, temperature, and even the freezing method. They all affect how we perceive the color of our red meat. Let's start with the main reason why our meat is red. It's because of myoglobin. So myoglobin, or this is a hemipigment, is the principal pigment of fresh meat, and the form that it takes is prime importance in determining the color of the meat. So myoglobin is actually a generic term. It has subforms, or it has different forms which have different colors, which together affect our meat. So there are three pigments for myoglobin. We have the regular myoglobin, abbreviated as MB. We have the oxymyoglobin, abbreviated as O sub 2 MB. And we have the metmyoglobin, abbreviated as met MB. So these are our three main group categories for the myoglobin pigment. Okay, let's start with the regular myoglobin, or MB. It is also referred to as the oxymyoglobin, and it is usually purplish in color. So take note of the third bullet here. It predominates in the absence of oxygen. So if there is no oxygen, the dominant color would then be that of myoglobin, which is purple. Second pigment is the oxymyoglobin, which is the O2MB. This myoglobin is actually bright red in color, and this results when the purple MB is oxygenated, or when we say oxygenated, it is exposed to oxygen gas, which produces the familiar bloom of our red meat. This is what we want. Okay, this is what from the Philippine or Filipinos, this is what we want to see. Okay, red. We want the meat to be red, and therefore, for it to be red, it should have a dominant pigment of oxymyoglobin, which is affected by the amount of oxygen in the air. The third color, or the third pigment, is the metmyoglobin, which is colored brown. So this exists when the O2 is at a very low concentration of 0.5 to 1%, if or when the meat is also exposed to air for a very long period of time. So the O2 MB will become met MB if the concentration is either very low, it's not very low, it's just low, 0.5 to 1%, or if you have exposed that meat to oxygen or to air for a very long time. Now, the dominant color is the one that we actually see. Also, take note that it's not just one pigment which we can see. It's actually a combination. It's possible that that the meat will have all of those three pigments together, but one of them will be dominant, or they could intermix with one another so that we could see somewhere along the colors of red, purple, and brown. So depending on the amount of oxygen in the air and the kind of pigments in the layers of our meat product, then we will see the particular combination of color, red, brown, or purple. Take note, this is a cyclical color, wheel, whatever. Okay, it's cyclical. What does that mean? The color would change depending on the conditions of the environment. So let's start here, okay, with the MB, the deoxymyoglobin, or simply myoglobin MB. It's purple, right? Okay, it's purple if it is in 0% oxygen. That means it's anaerobic condition. If there is no oxygen in the air, the meat will become purple. Now, we're not saying the meat is bad. We're not saying the meat is not good. Okay? It's just it is colored purple. So it could still be good. It could still taste good, but it's just colored purple. And that has a psychological effect to our consumers. We don't want to buy purple meat. Okay? Depending. Okay? It depends. Actually, there are some culture which do not like red meat. They would like a different color of meat. But here, for example, most of the Westerners and even us Filipinos, we want it to be red. So in order for the purple color to become red, we have to oxygenate it. Okay? Oxygenation simply means exposing it to an environment with high oxygen. For example, air. Regular air is again 21% oxygen. So the moment you expose it quickly to oxygen, it will become O2MB. So it become bright red in color, or oxymyoglobin. Now, what would happen if we're going, okay, if we're going to, let's say, leave it in air for a very long time, the oxygen will start to oxidize, okay, with the meat. Therefore, in a process called auto-oxidation, it will slowly make the color turn to brown because of the met MB being formed, or met myoglobin, okay? Now, if you're going opposite ng oxidation, by the way, oxygenation and oxidation are different. Oxygenation simply means the presence of air or oxygen, whereas oxidation means there is a transfer of electrons. Okay? Now, if the opposite of oxidation, as we all know, is reduction. If you're going to reduce your met MB, it will go back to purple, which is the myoglobin, which is the regular myoglobin. It will also go the other way around. Okay, it's just the same. So if you're going to expose MB, okay, expose your meat product in air which is not high oxygen, you're going to expose it in a low oxygen, about 0.5 to 1%, and it oxidizes. It will become brown. If you're going to expose it to oxygen plus there's a reduction reaction, it will become red. And when you're going to remove the oxygen so that there will be no more oxygen in the air, the red will become purple again. So it will just rotate around the colors depending on the environment. But of course, our goal, if we really want to sell our meat, is to make our consumers like our product. That would be the O2MB for the bright red color. So obviously, we all know that oxygen plays a very crucial role in the color of our red meats. So at 0% oxygen, we know MB is the dominant form. At 0.5 to 1% oxygen, we have met MB with low oxygen levels. And over 4% oxygen, including the regular air that we have, that we breathe, we produce O2MB, which is the bright red color, which is the one that we want. So therefore, we want oxygen, okay, for our meat products to have that bright red color. Of course, oxidation and reduction are also caused by oxygen, which is a slower reaction compared to oxygenation. And we have already discussed that in that chart. Okay. Okay, there we go. The loss or gain of electron. Okay, it's in the blood, blood pigment. Okay, which creates a difference in colors. Remember, our blood has iron. Okay, what else? Other than the oxygen, we also have the intensity of color. Okay, and the color intensity, which affects obviously the color that we see, is affected by both ante-mortem and post-mortem factors of the animal concerned. When we say ante-mortem, that means before we kill this animal, and the post-mortem is after we kill the animal. Look at that pig and that cow. Okay, we kill them and eat them, and their particular condition before and after being slaughtered will also affect that color that we will see. Let's start with the ante-mortem factors. This includes species, stress, age, gender, etc. Of course, we all know there are some species of cow or sheep or goat or pig which are better than the others. We also know that the male and female also have an effect on that. Of course, age will have an effect on that. And then look at the stress, of course. We'll talk about this later. How stressed the pig is before you killed it will also affect the color that you will see afterwards. Meanwhile, post-mortem factors would include the pH level after slaughtering, okay? Because it's very important or very critical to what we call the WHC or water holding capacity of our meat product. Okay. So difference in color intensity is also affected by the concentration of MB, which is inherent in the different kinds of animals that we have. Beef is the darkest of the meat species and has the highest MB concentration. So we all know beef looks dark, okay? Lamb is intermediate in color, while pork is the lightest and has the lowest MB concentration. That is why your pork is a little bit even white, okay? It's almost white. It's not even red, okay? It's like white, okay? Compared to beef, which is almost brown, purplish brown in color. So take note of that, okay? We're not dealing with poultry here, okay? Red meat does not involve poultry, by the way. So that would be it. So the type of meat would actually really dictate the color that we see, obviously. There are also two conditions of meat or two categories of meat that we have to learn. That will be the PsE and the DFD. So PsE means pale, soft, and exudative, while DFD means dark, firm, and dry. Let's talk about them. What is PsE meat? PsE meat, again, it means pale, soft, and exudative, and this is caused by short-term violent excitement of the animal before slaughter, which led up to the build-up of lactic acid. So in short, the animal was shocked before you killed it, and because it's shocked, diba? When you're shocked, you turn white, you turn pale. Namutla ka, nang lapsi ang animal bago siya ginpatay. And that's not a joke, it happened. It happens, and then the meat would more or less be PsE. Okay? So if the animal knew it will be killed, it sees the axe or the knife, and it got violent excitement, then the meat that would happen would be pale, soft, and exudative. Okay? For the after effect or the, let's say, post-mortem, it can be caused, okay? PsE meat can be caused by slow cooling of meat after slaughter. Now, what would happen if our meat is PsE? Then it would cause problems in packaging because the meat is abnormally pale and it scatters light. Okay, so it looks pale. Okay, we want red. Okay, other than pork, for example, we want red meat, but because the meat is PsE, it looks rather pale. Okay, so that's pale and it's soft. Okay. And exudative, by the way, sorry, exudative means it has an exudate, okay? Or just think about it that it's wet and it has some kind of fluid, okay? We call that drip, okay? So the PsE meat actually produces excessive drip. If you're going to squeeze maybe the meat, there would be excessive drip compared to DFD meat. Take note of that. This is also maybe one of the reasons why our slaughterhouses right now, they use some kind of, let's say, more not so violent means to kill the animals, okay? If in the past times we use hammer and mallets and axes to kill the animal, we just have computers which just fry the brain of the pig now, okay? So they won't know what hit them, they just died, so they don't have this short-term violent excitement. So that could be the reason why they're being killed without having to stress them, without having to excite them, rather. The second type of meat is what we call the DFD meat, okay, dark, firm, and dry. This is caused by excessive stress or exercise of the animal before slaughter. For example, you have to transfer the cow from from Capiz to Iloilo, and then you kill it here in Iloilo. Of course, the cow was stressed along the way, okay, during the travel from Capiz to Iloilo, and then when it reached Iloilo, before pa siya makapahuway, patay mo na siya. Stressed, okay, nag-exercise lang ang baka. Hence, okay, that the meat that is produced is DFD, or dark, firm, and dry. Another reason that DFD meat is produced is because of the low residual glycogen level during the time of slaughter. Now, DFD meat would cause problems in packaging because the meat is swollen and tightly packed, and it forms a barrier against oxygen diffusion. So it does not really look good, okay? And it's really dark, okay? If of course it's the opposite of PSE. So usually beef, cattle, and hogs are the common animals for DFD meat. So we also have differences in them regarding their pH levels, and then of course here we have the drip. So the normal meat, for example, has a pH of 5.7. It has a regular drip. If it's PSE, you shocked the animal. Look at the colors, for example. You shocked the animal before you killed it. The meat, because of the lactic acid buildup, becomes the meat has a pH of 5.2, and it has a lot of drip. So this is more acidic. Whereas for if you had it exercised or you stressed it out before killing it, it became DFD. It has less drip, as you can see, very little drip, and it has a higher pH compared to the normal level. So again, they have problems in packaging because obviously they affect the color of our meat. Now, what about the effect of other gases? Okay, this after knowing about those species, we'll talk about the effect of other gases. Okay, in your book, it discussed a lot of studies and research done about the effect of carbon dioxide on our meat. However, a lot of those studies and research are non-conclusive, okay? One study would say this, another study would say another thing. Hence, it's confusing. So, it's not yet, okay, conclusive for now. Meanwhile, we have here carbon monoxide. It has been found out that carbon monoxide can retard MET-MB formation, that's the brown one, and produce what we call carboxymyoglobin. So it actually produces another kind of myoglobin known as COMB, which is actually cherry red, similar to O2MB. Okay, so the color is very similar to O2MB. However, since again we all know carbon monoxide is a toxic gas, it is not been approved by regulatory agencies. Of course, we could die, okay, if we are exposed to carbon monoxide as human beings. So I'm not sure how safe, okay, and even if we know that that meat was, packaged in or flushed with carbon monoxide, we might have reservations eating that meat. So it's not approved yet by regulatory agencies, but that's just one of the results of their research studies. What else affects color? We have lighting. Okay. It's very obvious, right? Okay, even us, when you take selfies, you all know light is very important. Playing with light is very important when it comes to photography, and therefore it's also the same when it comes to the color of our red. That is why in our marketplaces and wet markets, the bulb there is colored yellow, okay, instead of white, because yellow at least has some kind of reddish, maybe reddish spectrum of light. It could give a reddish color to our meat compared to bright white light. Take note of that. Light also affects a meat in when it comes to discoloration, but it's not really that much. Okay, not really that significant. Another thing that affects our color of meat is temperature. Okay, now we have here the optimum temperature for the storing of chilled meat. So this is the minimum temperature that can be achieved wherein you do not damage the tissues of our meat. Remember, if you're going to freeze your meat or even your fruits and vegetables, tissue damage is being done because of the freezing process. Now here, the best temperature, which gives enough chilling benefits without damaging the meat or the fibers of the meat, is negative 1.5 plus minus 0.5 degrees Celsius. So memorize that one. So amo na ang pinakanami gitani negative 1.5 plus minus 0.5 degrees Celsius. Also, we have to consider the gas composition with its combination to temperature. If you're going to store it aerobically, okay, with oxygen, the rate of discoloration will increase linearly with temperature. That means the higher the temperature is, With the presence of oxygen, the higher the discoloration of our meat products, which is an obvious thing. Okay, if the temperature is low, you freeze it, you put it in the ref, then discoloration can be controlled. For anaerobic storage, the color stability actually increases at first and then it just declines. Okay, so it looks like a bell curve or an upside down V if that happens. So the rate at which color stability degrades is twice as fast as at 5 degrees Celsius and 4 times as fast as 10 degrees Celsius compared to 0 degrees Celsius. So it becomes faster. And finally, the freezing. Okay, the type of freezing also affects how our consumers perceive the color of our meat. For example, slow freezing produces large ice crystals with poor light scattering properties, which gives the meat a dark, translucent appearance. Hence, if your meat is PkgE meat, you might consider slow freezing in order to give it a darker appearance. On the other hand, fast freezing produces small ice crystals with scattered light and make meat surface pale and opaque. And of course, if you have DFD meat, you could do fast freezing to make it look paler. So take note, the rate of freezing would actually affect, okay, the color. And it's not just for meat, it also affects a lot of other stuff. Remember our polymers, the faster you freeze your polymers, the clearer it becomes. Okay, so that's the same with our meat products. The type of freezing affects how we perceive color. So in frozen red meat, the principal deterioration is photooxidation. So by the name itself, the effect of light. Okay, so reducing the light intensity by 90 to 95% can improve the shelf life of red meat by 5 to 10 times. And again, that's the reason why our refrigerator have no light if it's closed. So reduce light and you reduce a lot of problems. So that's it for our discussion on color. Our next video will be about microbial spoilage. I'll see you in our next video.